Hello everyone. Today I will present this demo, Security of Camera-Based Perception for Autonomous Driving Under Adversarial Attack. This is work from the S-Guard at UC Irvine. I'm Chris, and my co-authors are Ningfei, Takami, and my advisor Alfred. Perception is crucial to ensure safe driving in autonomous driving systems. AD systems leverage multiple types of sensors, including cameras and LiDARs, to detect surrounding obstacles in real time. LiDAR is particularly good at detecting obstacles, but its sensors can be prohibitively expensive. For this reason, companies such as Tesla have opted to use camera and radar for their AD perception. Much of the prior work involving adversarial hiding attacks targets traffic signs. The three papers listed here all include adversarial hiding attacks against stop signs. The images below are examples of successful adversarial obstacle hiding attacks. Our attack expands upon prior works by demonstrating end-to-end impact against representative AD system Baidu Apollo using a production-grade AD simulator LGSVL. For our attack plan, we use a modified expectation over transformation to generate a patch against the camera-based perception in the target AD system. In this case, this would be a YOLO object detector. We then apply the patch to the back of a box truck and test using LGSVL simulator. Our attack scenario is a self-driving vehicle driving behind a truck in a single-lane road. In one case, the back of the truck is unmodified or a benign patch. In the other case, the truck has an adversarial patch applied to the back, making the truck undetectable to the victim AD system. Here I have an end-to-end attack demo of this scenario. The top left visualizes 2D bounding boxes, the bottom left visualizes 3D bounding boxes, and the right shows all detected lane lines and obstacles via bird's eye view. First, we'll examine the normal case. As can be seen, although the truck detection flickers as is common with vision-based AD systems, the truck is detected in sufficiently many frames to prevent a crash from occurring. Now we'll examine the adversarial case. In this case, the truck is not detected in any frames and thus the vehicle freely accelerates, resulting in a crash. Thank you for your attention. For further information or questions, please email either of the listed email addresses or visit our website using the QR code shown here.